Hello everyone, welcome to MG Academy. The next topic in data structure is trees. So starting with the definition, tree is a non-linear data structure which organizes data in a hierarchical structure. So far we have studied linear data structures like queue, stack along with their implementation. And now we are starting with the non-linear data structures. So tree is a non-linear data structure. Why it is called as non-linear? Because it arranges data in a hierarchical structure. So whatever the data elements are present into the tree, they are arranged in a hierarchical manner. Okay. So this is a tree. Now if we draw an edge between B and C like this, so can we call it as a tree? No, this is not a tree. Trees doesn't have any closed region or loop. So we can write here as trees does not have any closed region or a loop. Okay. Now let us see what are the basic terminologies of trees, and these terms will be very useful in understanding other concepts of trees and will be used repeatedly. So it is very important to understand them in detail. Now the first is node. What is a node? Element of a tree is called as node. For example, consider this. In this tree you can see there are 8 nodes. A, B, C, D, E, F, G, H. So these are 8 nodes of the tree. Means these are elements of a tree which are called as nodes. So we can write it here as A, B, C, D, E, F, G, H. So these are 8 nodes. Okay. Now what is a root node? The starting node of a tree is called as a root node. Here the starting node of a tree is A. So we can write here as node A is the root node. Okay. And any tree has only one root node. There are never more than one root node. Okay. The third term is the edge. Link or connection between two nodes. The two nodes are connected with the help of a link, and that link is nothing but a edge. For example, A and B, node A and node B is connected by a link, and that link is nothing but the edge. Okay, and there is a relation between the number of edges and number of nodes. So we can write here as, if there are n nodes in a tree, and nodes in a tree, then there are n minus 1 edges. Okay, so if there is n nodes in a tree, then there are n minus 1 edges. Okay, so we'll consider this tree. How many nodes are present in this tree? 1, 2, 3, 4, 5, 6, 7, 8. So nodes are 8, isn't it? So according to this formula, the number of edges must be 7. So let us count 1, 2, 3, 4, 5, 6, 7. Yes, the number of edges are 7, isn't it? Now the next term is parent. So nodes with branches from top to bottom is called as a parent node. For example, consider here node A. Node A has 2 branches which lead to node B and node C. So node A is a parent node. Similarly, node B has 3 branches which leads to node D, E and F. So node B is also a parent node, and similarly node E. So in this tree there are 3 parent nodes, and which are they? node A, B and E. So these three nodes are the parent node. Now what are child nodes? So node with edges from bottom to top. So those nodes which have edges from bottom to top, those edges are called as, those nodes are called as child nodes. Okay, so here see, node B has an edge from bottom to top which leads to node A. So node B is a child node. Similarly, node C, isn't it? So these all are child nodes. D, E, F, they lead to node B. That is, they have branches from bottom to top, isn't it? So D, E and F are the child nodes. Similarly, G and H are also the child nodes. So we can write it here as node B, C, D, E, F, G and H. So these 7 nodes are the child nodes. Okay. Now what is sibling? Child node of same parent. Same parent child nodes are called as siblings. For example, your parent node is A and B and C are its child node. So node B and C are the siblings. So similarly, D, E, F are the child nodes of parent B, isn't it? So D, E, F are the siblings. So we can write it here as B, C, siblings, isn't it? D, E, F are siblings and G, H. Because node G and H also have same parent, that is E. So G and H are also siblings, right? Now the next term is leaf. So what are leaf nodes? Nodes without child are called as leaf nodes. See in this figure, node C has no childs. So node C is a leaf node. Similarly, nodes D, F, G, H have no childs. So these nodes are also leaf nodes. So we can write here as node C, D, F, G, H are leaf nodes. Okay. The next term is internal nodes. What are internal nodes? Nodes with child are called as internal nodes. In this tree, node A has 2 child nodes, B and C. So node A is an internal node. Similarly, node B has 3 childs. So node B is also an internal node. Similarly, node E. So we can write here as node A, B and E are the internal nodes. Okay. The next term is degree. What is the degree? Number of child nodes represent degree of nodes. So there are 2 types of degree. First is degree of node and the second is degree of tree. What is degree of nodes? The number of child nodes represent degree of nodes. For example, in this tree, node A has 2 child nodes. So degree of A is 2. Write here as degree of A is 2. Okay. Similarly, node B has 3 child nodes. So degree of node B is 3. Degree of B is 3. Okay. Now what is the degree of tree? So degree of tree is maximum degree among all nodes. See, degree of E is 2. The maximum degree is of node B. So degree of tree will be 3. You can write here degree of tree equals to 3. Okay. Now the next term is level. So what is level? every step from top to bottom in a tree is a level. We know that data is arranged in a tree in the form of steps, isn't it? And every step from top to bottom, here is the top and here is the bottom. So from top to bottom, every step in a tree are called as levels. Okay, and always level starts from 0. So we can write here as level 0, and then the level is incremented by 1. So the next level will be level 1, then level 2, and then level 3. Okay, so in these 3 there are 3 levels. So the level of tree will be 3. We can write here as level of tree is equal to 3, and level of root will be 0. The root node is at level 0. So we can write here as level of node is 0. Okay, the next term is height. What is height? Longest path from leaf node to that node. For example, if we want to find the height of a particular node, for example, consider node B. Node B, height. So if we want to find the height of node B, then we will consider a leaf node. For example, if we consider leaf node G, then what will be the height of node B? G to E, then E to B. 1, 2. So the height of node B will be 2. Okay. Now you will be thinking like, why we are not considering node D, isn't it? Node D is also leaf node, but we have clearly mentioned here that longest path from leaf node. So if we consider node D as a leaf node, then height of node D will be 1, and we have to consider longest path. So we will consider node G, or we will consider node H as a leaf node to find the height of node B. Similarly, if we want to find the height of node A, then we can consider either G or H as leaf node. Then height of node A will be 1, 2 and 3. So height of node A will be 3. The next term is depth. Longest path from root node to that node. So opposite of height is depth. If we want to find the depth of a particular node, for example, if we want to find the depth of node D, then we have to consider its distance from node A, which is the root node. Node A is the root node, isn't it? So what will be the distance? For let me write here node D. We want to find the depth of node D, and the root node is A. Then from it will travel from A to B 1, and then from B to D 2. So the depth of node D will be 2. This is for your understanding, okay? So depth will be 2. Similarly, if we want to find the depth of node G, then its depth will be A to B 1, B to E 2 and E to G 3. So node G depth will be 3. Okay. Now the next term is path. So what is a path? Sequence of nodes from root node to leaf node. It is a path. For example, consider this tree. This is a root node and this is a leaf node. So for traveling from A to G, we have to travel node B and E also. So these forms a path. We can write here as path A to G. So what is a path for traveling A to G? It is A, B, E, G. Okay, so for traveling from root node A to leaf node G, we have to travel node B and E also. So these forms a path like this. Okay, and finally we'll reach to G. The next term is subtree. So what is a subtree? Nodes with children forms a subtree. Consider this tree. A has a child B, child node B. So this will form a subtree like this. Okay. Similarly, node B has node E as a child node. So it will also form a subtree like this. Even A and C forms a subtree. Okay, so these were the basic tree terminologies which you need to understand before studying more concepts related to the trees. And that's it for today. Hope you understood my today's lecture, and if so, then give this video a big thumbs up, subscribe to my channel and share it with your friends.